Hi, my name is Hwang, and I'm going to be talking about Lab 1 with charge tapes. So the purpose of this lab was to determine how much excess charge was on one piece of tape, and we created these charge tapes by sticking two pieces of tape together and ripping them apart quickly. And in order to determine the charge of each tape, I had to use fundamental physics principles such as the formula for electric field, electric force, and gravitational force. In order to create these charge tapes, first I got a 0.2 meters long piece of tape and created a handle and stuck it onto a flat surface. I used my table. And then I got another piece of tape of the same length and I put it on that piece of tape and then I ripped it off quickly and that created an electrically charged U-tape. And then I created another charge tape by repeating steps 2 and 3. And then I got one of the U-tapes and put it on two textbooks. I put each edge on one textbook, and then I got the other U-tape and put it under it, and then the upper U-tape started floating. And then right when it started floating, I recorded the distance in between the two tapes. Some observations I had during the experiment were that when I put two U-tapes close to each other, they repelled each other, and this meant that they had the same sign. And then when I put the U-tape close to a neutral object, like my hand, it was attracted to it. And then when I put it close to a negatively charged object, it was attracted to it also. And I was able to test this because I got a plastic pen and then I rubbed it through my hair, which meant it was negatively charged. And then I put it towards the U-tape and then it was attracted, which meant that the U-tapes are positively charged. Because the tape is around 1 gram per meter, I was able to determine the mass of the tape. I did this by multiplying the length to 0.001 kilogram, which is the same as 1 gram per meter. And this gave me 0.0002 kilograms. And I recorded the separation distance when the upper U-tape started floating, and that was 0.025 meters. Because the upper tape was floating, I was able to assume that the net force on the upper U-tape was 0, and this meant that the force of gravity was equal to the electrical force. And you can see here my calculations, and when I solved for Q, I got 1.1667 times 10 to the negative 8, and then I was able to create or calculate the number of excess electrons by doing Q divided by the charge of an electron, and that was 1.167 times 10 to the negative 8 divided by negative 1.6 times 10 to the negative 19, and that gave me roughly 7.29 times 10 to the 10. I then found the number of atoms on the sticky surface of tape by first finding the area of an atom, and they told us that the length of an atom was 1 times 10 to the negative 10, so I divided that by 2 to get the radius, and I squared that and multiplied that by pi, and that gave me 7.85 times 10 to the negative 21. And then I divided this by the surface area of tape to get 5.092958 times 10 to the 17. And then I found the ratio of excess electrons to number of atoms on the sticky surface by getting the number that we just got and dividing it by the number we got before. And that was 7.292 times 10 to the 10 divided by 5.093 times 10 to the 17. And that gave me 1.432 times 10 to the negative 7. When coding, I had to make several assumptions when I made my computational model. First, I had to ignore air resistance on a moving object. So when the upper U-tape floated, I had to ignore the air resistance that acted on it when it moved up. And I also treated each long tape as though it was a point charge with all the charge concentrated on the center of the long tape. And I also assumed that each U-tape had about the same amount of charge and it was evenly distributed along the length of the tape. Here you can see my computational model. The particle on the top represents the upper U-tape and the particle on the bottom represents the lower U-tape. And this yellow arrow is the electric force and this red arrow is the gravitational force. And you can see that the electric force and the gravitational force are equal, which shows that the net force is 0. And also the amount of charge I got on each tape when I did this computation model is 1.167 times 10 to the negative 8, which is the same as the charge I got when I did the calculations by hand. And the electrical field of each tape is 1.68 times 10 to the 5, and the electrical force of each tape is 1.962 times 10 to the negative 3. So if electrons had a positive charge and protons had a negative charge, it wouldn't matter. The observations I had with the tapes and the other charged objects would be the same. For example, if I got two U-tapes together, they would still repel each other because they're the same charge. And if I try to put my hand with the tape or the plastic pen with the tape, it would still attract each other because they're opposite charges. And why is it important to handle the charged tapes as little as possible? It's because when you put your hand on the tape, the excess electrons from the tape will try to go to your hand because they want to be in equilibrium and move to a larger space where there's less electrons.